So here we go with nothing new. This is just my attempt at giving you another example of how to do everything with a polynomial function. And by everything, I mean the x and y-intercepts, finding the maximum or minimum points, finding the points of inflection. And when somebody says find the maximum minimum points, they're actually saying find and indicate if it's maximum or minimum, which means you have to do the first derivative test, and the points of inflection kind of include concavity, so you have to do the second derivative test. So I've got 3 slides set up for this. I don't even know if that's enough. These are gigantic questions. I will warn you that this one is worse than average, and by worse I mean longer. So that means hand cramps for me. This is the stuff in your book that you can work on. I'm going to start this question the same way as I started the one from yesterday, and that is I am going to take the first and second derivative before we even start. That guarantees me a place where I feel comfortable. So 4x cubed minus 9x squared plus 6x minus 1. And y double prime, second derivative, 12x squared minus 18x plus 6 minus 0. All right, so the first thing I'm going to do now that I've gotten my derivatives out of the way is to take care of the x and y intercepts. So I'm going to do that, both of them in black pen. So the x-intercept is where we let y equal 0. So that's 0 equals, and I'm going to do something while we're taking care of this, and that is I am going to take an x out of each term. So x times x cubed minus 3x squared plus 3x minus 1. And here's the part that you may not love about this question is in order to factor this bracket, you're going to have to do long or synthetic division. Now, because this is still set up the same way as we did in polynomial functions, I can do either long or synthetic division. I'm going to do both. So the first thing I have to do is pretend like it's a question kind of off to the side, and I'm going to call it f at x. So it's like a question in a question, which happens quite often in higher level math, and calculus is higher level math. And I'm pretty sure 1 works. So 1 cubed minus 3 times 1 squared plus 3 times 1 minus 1 is 1 minus 3 plus 3, so they'll cancel, minus 1, so they'll cancel, and I end up with 0. So that means I can synthetic divide with 1x cubed, negative 3x squareds, 3x's minus 1, drop this down, multiply, add. Multiply, add. Multiply, add. If you don't get a 0, something went wrong. Now, for those of you who are long dividers, I'm just going to provide that solution for you here as well. So this might take a little longer or a little more space for me than it will for you, because you probably won't do double methods. So this is what we're trying to divide up. And I found that 1 worked, so that's x minus 1 out front. X goes into x cubed, x squared times. Multiply around, that's x cubed, they match, yay. Minus 1 x squared. Subtract these two, gone. Negative 3 subtract negative 1 is negative 2x squared. Bring down the rest. X into negative 2x squared is negative 2x. Multiply around, they match, yay. Plus 2x. Subtract, they'll match, this is 1x minus 1. Then I need to take the x out front, divide it into 1x. That's positive 1. So that's 1x minus 1, and we get a remainder of 0. So both methods get us exactly the same answer, whether it's this way, where this is an x cubed, that makes this 1 less, so x squared, 1 less than that, 1 less than that, which is the same as what's sitting here. So this black bracket right here can turn into x minus 1 from what we divided in times the x squared minus 2x plus 1 with the x out front equals 0. And then this gets factored again. So two numbers that multiply to be 1 that make negative 2. And what I notice is that I've got 3 identical brackets, so I'm going to write it like this. And remember, we are finding the x-intercepts, and x-intercepts are roots. So that means when I dig out the old green pen, I'll get x equals 0 and x minus 1 equals 0. I will have x-intercept answers of 0 from this one and 1 from this one, but this is going to be a point of inflection that I should end up with later, and it's a point of inflection that's on the x-axis. So that's because this is to the 3. Now, if you didn't notice this, if you didn't notice that this happened 3 times, which makes it a point of inflection, that's okay. It'll all fall into line anyhow. So, next thing I'm going to have to do, write the question down again. Hopefully I'll be able to clone this. Whoa. And if I clone it, I'll be able to drag things around and not really worry about it. Okay, that's clonable. Okay, so I'm going to keep it up there just in case I need another copy. And the next thing I'm going to do, still with black pen, is I'm going to find the y-intercept. And because there is so much going on in these questions, which is actually less than when we do it with rationals, and that comes next, we do have to label our work. So I am about to find the y-intercept, which means I need to let all the x's equal 0, which means the y-intercept is 0 because this will be 0, and 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 we have no constant, so we end up with 0. Which shouldn't be a surprise because every time you have an x-intercept of 0, you have a y-intercept of 0. So, what I'm going to do now is I'm going to the next page to talk about max, min, and points of inflection. And I'm actually going to make a new page so that the third page is all about points of inflection and the second derivative test, and then on the final page I'll have the picture. So if you're doing this on paper, my advice is not to flip. So have it on front, 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 or however long it takes you. I know that I would be able to do this in less space on paper than I do on the smartboard pieces of paper. So I need this on my next slide, and I need this cloned on my next slide, and I need this cloned on my next slide, just in case. And I'm going to undo this, delete page, because now I have all the necessary pieces of information on this page. And to save me doing everything again, I'm just going to clone the page. So this is going to be my max min points of inflection, max min first derivative test page. So I am going to find the max min here, just because it's kind of wasted space. So the max min means that we have to take the first derivative, which is this, and we have to let the first derivative equals 0. So you can do that with a 0 on the left or a 0 on the right. So I'm going to put a 0 on the right. And the unfortunate part about this is that we have a cubic. And the Wayne-Gretzky method will fail with this cubic, so we are stuck doing long or synthetic division again. Now, I'm not making this too difficult because I can tell by looking at this, and I'm going to use purple again just to break out over here. And I'm going to call f at x, so this is not the y's from the question. This is f at x. I'm going to call 4x cubed minus 9x squared plus 6x minus 1 f at x. And I'm going to do all my long division, then I'm going to come back here. So my purple is like scribble work that gets me over to here. It's not going to appear out of nowhere, and it is worth marks if you're doing this. So this is me being extra cruel with the question because it takes more than basic factoring. And like I said, I am kind of being nice because I'm pretty sure that 1 works here as well because all my coefficients cancel out. So when you put 1 in, it's really like doing nothing and just paying attention to the big numbers. So this is 4 minus 9 plus 6 minus 1. So it's just the numbers that you see when you put in a 1. And here's 10 negatives, and here's 10 positives, so that's 0. So we know that we can either long or synthetic divide with a value that's going to work. So 1 out front, 4, negative 9, positive 6, negative 1, drop the 4. Multiply, add, multiply, add, multiply, add. Better end up with 0. And I'm going to assume that I'm not going to take up too much space, so I'll show the long division here to make everybody happy. So that's what I'm dividing in because 1 worked. 4x cubed minus 9x squared plus 6x minus 1. X into 4x cubed is 4x squared. Multiply around, yay, they match. They cancel, be careful. Negative 9 subtract negative 4 is negative 5x squared. Drop down the other stuff. X into negative 5x squared is negative 5x. Multiply around. They cancel, that's 1x minus 1. Divide in again. Better end up with 0. So after either long or synthetic dividing, 4x cubed, 4x squared, x, you are going to get this cubic broken down into the x minus 1 that you divided in, and the 4x squared minus 5x plus 1 equals 0. And I'm just praying that this is factorable rather than quadratic formula. So 2 numbers that multiply to be 4, 2 numbers that multiply to be 1, make negative 5, negative, 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 totally works. Woo! So we get that. And green pen. Not going to write that one down again. Actually, I am going to put this down here now that I'm done. I have that luxury. And I end up with x values of x equals 1, which is not a double root, because we are not finding roots. We're finding max mins. And also a quarter. So I have to take those according to my list of rules. Please refer back to them from the last two notes. You have to take those and you have to put them back into the original equation. The original equation being this thing. So I have to put 1 in there and I have to put a quarter in there. So putting 1 in. Sorry about my handwriting. That's 1 minus 3 plus 3 minus 1 is 0. So one of our maximum values is put in 1, get out 0. And then the other one, we have to do the same business with a quarter, either with your calculator or by taking care of fractions. It's 1 over 2 to the 6 is 64, 2 to the 7, so that's 256 minus 1 times 1 times 1 times 3 over 4 times 4 times 4, 64, plus 1 times 1 times 3 over 4 times 4 minus 1/4. So I'm going to get a common denominator, because I'm a math teacher. I can do this by hand, I think. So a common denominator will be 256. So times 4 to get 256 times 4. Times 16 times 16. Ooh. Times 64 times 64. Yes. So that's still over 256. So that's negative 68. Nope, negative 78. Plus 48 is negative 30. Plus 1 is 31, and I'm pretty sure that's not reducible, so I'm going to leave it. And I know that another max or min is put out a quarter. Sorry, put in a quarter, get out this. And yeah, I don't know what this is a decimal, but I know it's positive, and that's really all I need for a sketch. So there's no panic about not understanding what this value is. All you need to do is you need to compare it to other values. Now remember what the next thing to do is, and that is the first derivative test. And the first derivative test requires you to draw yourself a number line. And it's to put all the values you got up here onto that number line in numerical order. So I have to put a quarter on here and I have to put 1 on here. And then I have to go find my first derivative again. Because this is the first derivative test, and we have to test numbers to the left of a quarter, between a quarter and 1, and outside of 1. So I am going to put in 0 first of all, because that's out here. Now, some of you might see that I'm doing way too much writing, because all those are zeros, so I should end up with -1, and I really don't care that it's -1. I care that it's negative. And if it's negative, that space is decreasing. Now, also remember that I have a brand new version of the first derivative because I bothered to factor it. So if you don't like the straight up substitution method, which gets it a little bulky when the number you choose is not 0, then you could use either one of them. Either one of them will give you the same sign results, maybe not the same numbers, although it should give you the same numbers if you're being careful. So I'm going to pick a number between a quarter and 1, and a number between quarter and 1 is a half, which is bulky. So I'm going to put in a half, so x is equal to a half, either written as a decimal or a fraction. And then we're going to find out what the value of the first derivative is, because this is the first derivative test. So a half in here will result in a negative. A half in here, so half of 4 is 2, minus 1 is a positive, and a half in here is another negative. So 2 negatives and a positive results in a positive, so that means it is increasing. And then I can do it again, only I'm going to pick a number to the right of 1, so I'm going to pick 2. And I'm going to use the same method because I don't really want to plug 2 in here and use my calculator when I can use my brain, and it's simple. So 2 minus 1, 4 times 2 minus 1, 2 minus 1. Okay, so it looks like if I've got my picture, I'm decreasing, increasing, increasing again. So I know that this point right here is a min, and I have no idea what this one is at this point. At any time, I'm not going to do it now, at any time you can take all these values and all the values off the first page and you can start dumping them onto your grid. Totally up to you when you want to do that. I'm going to wait until I'm done the second derivative work, which is points of inflection and concavity. So point of inflection means that I have to take the second derivative and I have to equal it to 0. And I'm really hoping that this is factorable. So I know I can take a 6 out. And I'm pretty sure this is factorable. I'm going to at least try it. So 2 numbers that multiply to be 2, 2 numbers that multiply to be 1, 2, 1, and I need negative 3. I panicked there for a second because I thought I wasn't going to get positive 1, but I am getting positive 1. So my brackets, including the 6, would be 2x minus 1 and 1x minus 1. Okay, I'm super happy that I don't have to do that long division stuff. So 6 equals 0, garbage. 2x minus 1 equals 0 requires a little bit of work. And x minus 1 will not require, x minus 1 equals 0 will not require a lot of work. So I end up with x values, a half and 1. So they're going to go on my number line when I do my second derivative test. Now, while it's all sitting here, I'm going to remind myself that this is the second derivative, which I need for the second derivative test. And another version is this thing here. This is the second derivative as well. It's just the factored version. So we can use either or both of those on our number line. So put these values on the number line in don't want that. In numerical order. So a half comes numerically before 1. And then we have to test values. So I am going to test x equals 0. And because I've done this enough, I know that this one is the best one because this is 0 minus this is 0 plus 6. So I end up with the second derivative is 6, which is positive. So that's concave up, which looks like that. Then I need a number between a half and 1. So I'm going to use 3/4. And you can either use 3/4 like this, or 3/4 like this, or some other value that is between a half and 1. So if I do this in the second derivative, this is still going to be positive because it's just a 6. 2 times 3/4 is 1.5 minus 1 is positive. 3/4 minus 1 is a negative, so it ends up being a negative, which is concave down, which looks like this. So I have figured out that x equals a half is a point of inflection. I have forgotten, but can do this at any time, I have forgotten to find the y value for it, so I'll plug that in a second. The last one is x equals something to the right of 1, so I'm going to use x equals 2, and I'm going to put it in here. So y double prime is equal to 6, which is positive. 2 times 2 is 4 minus 1 is 3, which is positive. 2 minus 1 is 1, which is positive, so I end up with a positive, which is concave up. So I actually have 2 points of inflection because it does my alternating thing twice. Now, it goes back to this. What sometimes happens is what happened here, and that is you get a value, x equals 1, in max-min land that doesn't end up being a max-min. Remember that I put a little question mark beside it. What often happens is that you end up taking that value and it appears again here. So don't be surprised by that. But I can't really continue until I find the y values for my x values. Your choice about which one you want to find first. So I'm going to put in a half first and do the worst one. Which means some fraction work again, maybe. 1 to the 4, 2 to the 4. 1 times 1 times 1 times 3 over 2 to the 3 plus 1 times 1 times 3 over 2 to the 2. So my common denominator will be 16. So I'll have to double both of these, times both of these by 4, times both of these by 8. So 1 minus 6 is negative 5. Negative 5 and negative 8 is negative 13. Plus 12 is negative 1 over 16. So I have a point of inflection, because remember, we did the alternating deal over the 1/2. That's a half comma negative 1 over 16. Do not panic that you might not know the decimal version of 1 over 16. Last thing I have to do before I start plotting all this stuff, and remember that this gets different because we still have to do all this stuff with rationals after this, meaning fractions, meaning quotient rule. So there's my y, and oops, I've lost my x, it's a 1. And if you realize that you've already done this, in fact, twice, then you don't have to do it again. You can just steal your work. But I'm going to put it here so that everything's intact. 1 to the 4, 1 to the 3 times 3, 1 to the 2 times 3, 1, oh, and that's a point of inflection. Let's see what's happening over here. Okay, I hope this is working. Stop it! All right, whew. Okay, so, for now, here's the work in case you couldn't hear me talking through all that stuff. So now I'm going to start with my X. No! Leave me alone. My X-Intercepts. So I've got X-Intercepts of 0 and 1 and a Y-Intercept of 0, which will collide, so I don't have to have a really good memory for that. So 0 and 1. 0, and I'm going to spread this out and put 1 here. Next thing, max mins. So we found out that 0, 1, which is already on my graph, is a nothing, an unknown from the max mins. But we found out that a quarter and something slightly positive is a minimum. So I'm going to go to this picture, and I'm going to go to where I think a quarter is, which is here, and something slightly positive. Remember, this is a sketch. So I get to do whatever the heck I want within reason. 31 over 56, sorry, 256. Crap. Doesn't change anything. Can't believe you didn't yell at me when I did that. I was just thinking that doesn't make sense for a minimum, so that's my negative 78, and there's my plus 48, so that's negative 30. Plus 1. So much for my mental fractions. How about I do this? I am not doing this whole question again. You're going to have to deal with my mistakes. I'm a tired girl. I've already had a day of math. 1 minus 12 plus 48 minus 64 equals... Holy crap, I didn't even see that coming. 1 minus 12 plus 40. Oh my gosh, I'm so rusty. Really? Okay. Negative 78. No, negative 76. Oh, I can't believe you let me do that. Anyway, that means I get to take this point, which is not up there. It should be down here. See, it's crashing because I'm dumb. Still going. And this is a min. Before I forget. Don't know why that happened. All right. Finally. Points of inflection before this thing crashes on me. Point of inflection definitely at 0, 1. So I'm going to go to my grid, my fake grid, and I'm going to say, okay, regardless of what this looks like, I intend it to be a point of inflection. And then the other one that I hope I did right is a half negative 16. Sorry, a half negative 1 over 16. That's negative 14 plus 12 is negative 2 plus 1. Okay, I got that one right. A half, comma, negative 1 over 16. A half is greater than a quarter, but less than 1, comma, negative 1 over 16. And the question should be in your mind of why on earth is, oh, hang on. If I times that by 16 and times that by 16, I end up with negative 16 over 256, so it is less than, so it's less negative. So now I'm going to try to draw these pictures, or this picture. So I know this must come down and min out there, then it's going to do a little squiggle here and a little squiggle there. That's what's going to happen. So let's see if I can pull this off. So I have to draw it this way for me to connect the dots with this tablet. So it comes down, bottoms out, because this is a minimum, and then it's going to squiggle through there. So here's the thing about concavity that makes it helpful. We need to make sure we are concave up until a half. So we need to be like a bowl of soup till a half. And those of you with erasers can fake things a little bit better. Then, according this, we have to be concave down until we get to the 1, and then we have to be concave up again. Is this still working? It's still going. Keep your fingers crossed for me. Stop it. So I have to be concave down. I have to be concave up again. Concave up, and that's just to help me get this thing on paper point, along with any other intercepts that might happen. So aside from my blip in being able to add and subtract and technological problems, that's your question. So it's all got to fit together and hopefully save. I got to stop doing this when I'm exhausted. Don't do math when you're exhausted. Don't cram overnight. Just get some sleep. And I'm talking about when you go past high school. Anyhow, that's my rant for the day. Tips.